Good morning, students. Unit 4, the alkali and alkaline earth metals. Alkali and alkaline earth metals. In this session, I am going to teach the distinctive behavior of beryllium. The anomalous behavior. The anomalous behavior of beryllium. Okay, so beryllium, magnesium, calcium, strontium, barium and radium. You right? So the anomalous behavior of beryllium in second group with the other elements. With other all elements in anomalous behavior of beryllium. Right? So, on properties of alkaline earth metals. Okay. The distinctive behavior of beryllium. பெர்லியத்தினுடைய தனித்தன்மை மாறுபட்ட அல்லது வேறுபட்ட பண்பு. Right? The reason, the anomalous nature of beryllium is due to the smaller size. Beryllium is smaller size than in other elements in group 2. Smaller size and high electronegativity and ionization energy. High electronegativity and ionization energy. And third one reason, the high polarizing power. The high polarizing power. Okay. And fourth one, in absence of d orbital in valence cell. The absence of d orbitals in valence cell. So the anomalous behavior of beryllium due to smaller size and high electronegativity and ionization energy, high polarizing power and absence of d orbital in valence cell in other elements. Okay. So the comparison of beryllium and other elements of the family. The comparison of properties of beryllium then other elements of the family. The first one is forms covalent compounds. The beryllium forms covalent compounds. Right? The beryllium is smaller size. Beryllium is smaller size than in other elements in group 2. So magnesium, calcium, strontium, barium and radium. So beryllium is a very smaller element. So high polarizing. According to Pajan's rules, so the cation reacts with the anion. Okay, the nucleus attract the electron towards itself in the anion. You right? So the structure is destroyed to form covalent bond. But the other elements of the family form ionic compounds. Easily loss of 2 electrons. So easily loss of 2 electrons. So form ionic compounds. A high melting point and boiling point. The beryllium have high melting and boiling point. So beryllium is a very smaller elements. So very lightest element in this second group. But the metallic bond, the rigid metallic bond is formed between the beryllium atom. So lattice energy is high. So high melting point and boiling. But in other elements, so size is larger. So increase the size, so low melting point and boiling point. The third one does not react with water. Even at elevated temperature. So high temperature elevated temperature means high temperature. High temperature beryllium does not react with water. So due to smaller size and high ionization energy. Okay, so beryllium say smaller size and high ionization energy. The beryllium contain so smaller size and high ionization energy, so does not react with the water even at elevated temperature. But other elements of the family react with the water. Reacts with the water. The size is increases in top to bottom. Size is increases to top to bottom. The ionization energy decreases. The ionization energy decreases and size are also increases. So easily react with the water. Okay. So magnesium. So magnesium less than calcium and less than strontium and less than barium. Barium is a radium is a radioactivity element. So the reactivity, react with the water. So the magnesium is less than calcium, calcium is less than strontium and less than barium in strontium. Okay, top to bottom, the reactivity react with the water. The reaction tendency of water is increases. Are you right? So magnesium does not react with the cold water. So only react with the steam water H2O to give magnesium oxide and liberate hydrogen. But in calcium, strontium, barium react with the cold water. So barium react with the cold water to give barium hydroxide. And liberate hydrogen. Are you right? So barium hydroxide. So 2 hydrogen, 4 hydrogen. 4 hydrogen, 2 oxygen. Okay, so the order of reactivity increases top to bottom. You right? The fourth one does not combine directly with the hydrogen. You right? The oxidizing potential is very low in beryllium. You right? The oxidation potential. The oxidation potential is very low. Very low in beryllium. So smaller size. Very smaller size. The effective nuclear charge increases. Okay. In top to bottom, increase the size. The effective nuclear charge decreases. But in beryllium, the effective nuclear charge is higher. Smaller size. So oxidation potential is very low. Okay. So cannot easily donate electron with the hydrogen. So does not easily donate electron with the hydrogen. Are you right? So, but indirectly beryllium gives beryllium hydride. The beryllium chloride reacts with lithium aluminum hydride to give beryllium hydride. And lithium chloride and aluminum chloride is a byproduct. Okay, chlorine 3 plus 1, 4 chlorine, so 2. So beryllium 2, 4 hydrogen. Okay, so does not combine directly with the hydrogen. The oxidation potential of beryllium is very low. Okay, so cannot easily donate electron with the hydrogen. Very smaller size. Okay, so indirectly give beryllium hydride. Okay, so and halogens are also. The beryllium halide is a covalent in nature. Beryllium halide is a covalent nature. So beryllium halogens, beryllium halide, the beryllium oxide combined with the carbon and chlorine at 600 to 800 Kelvin to give beryllium chloride and carbon monoxide. So does not combine directly with the hydrogen and halogens. But the other elements of family combine directly with the hydrogen and halogens. For example, calcium directly react with the hydrogen to give calcium hydride. Calcium hydride. So barium directly react with the chlorine to give barium chloride. The reactivity tendencies increases to top to bottom. Top to bottom. You right? So the fifth one is the hydroxide and oxides of beryllium are amphoteric in nature. The beryllium hydroxide and beryllium oxides are amphoteric in nature. Amphoteric means so the both acidic and basic nature in basic beryllium hydroxide. The beryllium hydroxide is acidic and basic nature. So both nature, so amphoteric in nature. Okay, so for example, beryllium hydroxide reacts with hydrochloric acid to give beryllium chloride and water. Beryllium chloride and water. 2 chlorine, 2. Okay. So hydrogen 2 plus 2, 4. 2. Oxygen 2. And beryllium hydroxide reacts with sodium hydroxide to give sodium berylate. Na2Be 4 plus H2. Sodium berylate. Sodium berylate, right? 2 sodium, 2. So okay, so 2 sodium, 2 hydrogen. 2 plus 2, 4 hydrogen. So 4 hydrogen. 2 sodium, 1 beryllium, right? Oxygen. 2 plus 2, 4 oxygen. 2 plus 2, 4 oxygen. The beryllium reacts with the hydrochloric acid. The beryllium acts as a base. Basic in nature. Hydrochloric acid is a strong acid, so beryllium hydroxide acts as a basic solution. The beryllium hydroxide reacts with the sodium hydroxide. Sodium hydroxide is a strong base. Strong base. So beryllium hydroxide acts as a acidic in nature. Acidic in nature. So beryllium hydroxide acts as a basic in nature and react with the strong acid, and beryllium hydroxide acts as acidic nature and reacts with the strong base. So beryllium hydroxide is a amphoteric in nature. Beryllium hydroxide is a amphoteric in nature. But the other elements of the family basic in nature. Basic in nature. Calcium hydroxide, barium hydroxide. Barium hydroxide is a strong basic solution. Okay, the sixth one is not readily attacked by acids. Not readily attacked by acids. எளிதில் ஆசிட்னால இது அட்டாக் ஆகாது. ஏன் அப்படின்னா because of the oxide layer is occur in the surface of the beryllium. beryllium surfaceல beryllium oxide layer form ஆகும். அதனால இது ஃபர்தரா ரியாக்ட் பண்ண முடியாது. பட் readily attacked by acids. இங்க அந்த மாதிரி லேயர்ஸ் ஃபார்ம் ஆகாது. அதனால அட்டாக் ஆகும். Okay, so the seventh one is the beryllium carbide. The seventh one is beryllium carbide evolves methane with water. So easily hydrolyzed with the water. The salts of beryllium are extensively hydrolyzed. So evolve methane gas. But other family, in other elements of the family evolve acetylene. Evolve acetylene with the water. Right? So hydrolyzed. Normal hydrolyzed. Beryllium carbide. Beryllium carbide reacts with the water to give evolve methane gas and beryllium hydroxide gives. So beryllium carbide reacts with water, it gives methane gas and beryllium hydroxides. Okay, so beryllium 2, right? Hydrogen 4 plus 4 8, so 4. Oxygen 4, right? And other elements of the family, for example, calcium carbide. Calcium carbide reacts with the water to give acetylene, CH triple bond CH plus calcium hydroxide. Calcium hydroxide. Okay, so calcium carbide, carbon 2 carbon, 2 carbon. Hydrogen 2 plus 2, 4, so 2. Oxygen 2, oxygen 2, right? So the salt of beryllium are essentially hydrolyzed. So in other elements are normal hydrolyzed. Okay students, the diagonal relationship, the diagonal relationship between beryllium and aluminum. So already you know that in first group element, in first element lithium, okay, lithium, beryllium, boron, okay, so sodium, magnesium, aluminum. Okay, the diagonal relationship between lithium and magnesium, already you know that. In this class, I am going to discuss the diagonal relationship between beryllium and aluminum. The diagonal relationship between beryllium and aluminum. The size of these ions, beryllium and aluminum, the size of these ions is not as close. The radius of beryllium 2 plus 0.45 Armstrong and radius of aluminum 3 plus 0.54 Armstrong. The size of these ions is not as close. However, the charge per unit area is closer. Beryllium 2 plus, the charge per unit area 2.36 and aluminum 3 plus 2.50. So moreover closed value. And also same electronegativity values in beryllium and aluminum. Same electronegativity values, beryllium 1.5 and aluminum 1.5. So beryllium 1.5 and aluminum are also 1.5. Right? So the similarities between beryllium and aluminum. The similarities between beryllium and aluminum. The beryllium chloride form a dimeric structure like aluminum chloride with chloride bridges. Chloride bridges. Right? In beryllium 1s2, 2s2. Right? So in valence orbital 2s2, 2p0. So 2s2, 2p orbital. So 2s2 in ground state electronic configuration. Ground state electronic configuration, the beryllium reacts with the chlorine. In excited state, the electron shifted to 2p orbitals. The paired electron shifted to 2p orbitals. Right? So the beryllium chlorine give one electron in 2, 4, 6, 1. So valence 7 electron. So one electron donate the beryllium 2s orbital and another one chlorine. One electron in beryllium. But two vacant orbitals are available in beryllium chloride compounds. Beryllium chloride compounds. The two vacant orbital is available. So beryllium is a Lewis acid. Beryllium chloride is a Lewis acid. The Lewis acid means the accept the electron. The accept the electron is Lewis acid. Okay, so the beryllium chloride compound contain vacant orbital. So accept the electron pair. Accept the electron pair. So act as a Lewis acid. In ammonia, nitrogen, NH3, ammonia. So N7, 2, 5. In nitrogen, in outermost electron, 5 electrons. Okay, so in obey octet rule to available to occur 3 electrons with the hydrogen. Okay, H, 2, 4, 6, 8. So bonded electrons. The non-bonded electron or lone pair of electrons are available in ammonia compounds to donate the vacant orbitals contain compounds. Okay, so the electron pair donor Lewis base. The electron pair accept or Lewis acid. So beryllium chloride acts as a Lewis acid. Are you right? In structure of beryllium chloride, the beryllium, the structure of beryllium chloride forms a dimeric structure like aluminum chloride. So aluminum chloride, aluminium, Al, 13. 2, 8, 3. Okay, so 1s2, 2s2, 2p, 6, 3s2, 3p, 1. In valence orbital, 3s2 and 3p. Okay, 3d, 0. Okay, 3p orbitals contain 3s orbital contain 2 electron and 3p orbital contain 1 electron in ground state electronic configuration. Okay, in aluminum chloride, AlCl3 in excited state, the pair of electron transfer from 2p orbitals. Okay, so fluorine Cl in outermost 7 electron. Okay, so covalent bond is occurred. Okay, sharing of electrons in both aluminum and chlorine. Okay, so 3. So aluminum chloride cannot obey octet rule. 2, 4, 6. Only 6 electrons available, but the vacant orbital, 3p orbitals, 1 vacant orbitals are also available in aluminum chloride. So aluminum chloride are also as a Lewis acid. Aluminum chloride are also act as a Lewis acid. The dimeric structure of aluminum chloride. The dimeric structure of aluminum chloride, right? So the dimeric structure of aluminum chloride, the aluminum Al. Okay, so 3 chlorine. In another one, aluminum. 3 chlorine. Right? So 2, 4, 6 electrons only available in aluminum, in both aluminum atoms. Okay, so but chlorine 2, 4, 6. Okay, 2, 4, 6. So vacant orbital in aluminum, vacant orbital in aluminum. Okay, so the chlorine donate the pair of electron in the aluminum compound. This chlorine donate the pair of electron in aluminum. So the dimeric structure of aluminum chloride. So Al2Cl6. Al2Cl6. Okay, so the AlCl3 twice. AlCl3 twice. So beryllium chloride form a dimeric structure like aluminum chloride. So aluminum chloride dimeric structure. The beryllium chloride are also form dimeric structure, right? Dimeric structure of beryllium. Okay, Cl and Cl. Okay, so 2 vacant orbital in beryllium, 1s2, 2s2, 2p0. Okay, in excited state, in 2s2 electron. So 2 vacant orbitals are available in beryllium. Are you right? So in another one, beryllium chloride. Beryllium chloride. In another one, beryllium chloride. Beryllium chloride. Right? The chlorine contain 6 valence electrons. 6 electrons. Okay. So the one lone pair of electron to donate the beryllium atom. In another one, beryllium chloride, the chlorine donate the beryllium. The 2 vacant orbitals are available. 2 vacant orbitals. Are you right? So donate the electron. It's a dimeric structure. The beryllium chloride also form polymeric chain structure. The polymeric chain structure. Okay. So the polymeric chain structure. Continue the structure. Then chlorine and beryllium chlorine. Okay. So the chlorine donate the electron. Thus chlorine donate the electron to beryllium. Okay. So beryllium chloride also forms polymeric chain structure in addition to dimer. Both are soluble in organic solvents and are strong Lewis acids. Okay. So next one, the beryllium hydroxide dissolves in excess of alkali and gives beryllium ions. Beryllium ions and the hydrogens as aluminum hydroxide, which gives aluminate ions. Okay, so the beryllium hydroxide reacts with the excess of alkali to give beryllium ion, and aluminum hydroxide reacts with the excess of alkali to give aluminate ion. The beryllium hydroxide dissolve. Beryllium hydroxide reacts with the excess of sodium hydroxide to give sodium berylate ion. Right? Each sodium Na plus, so 2 plus. Okay. 2 minus. Each hydroxide ion minus 1, 4 minus, beryllium loss of 2 electron 2. 2 plus 4 minus, remaining 2 minus. Okay, the sodium tetrahydroxo. Sodium tetra means 4. The tetrahydroxo. The sodium tetrahydroxo berylate 2. Okay, the beryllium hydroxide reacts with the excess of sodium hydroxide. Okay, so 2. Excess of sodium hydroxide. 2Na. Okay, so 4 hydrogen. 2 plus 2, 4 and 1 beryllium. The beryllium hydroxide dissolves in excess of alkali and gives berylate ions, and aluminum hydroxide which gives aluminate ion. Okay, so aluminum hydroxide. The aluminum hydroxide reacts with the excess of hydrogen. Okay, so 2 minus, 1 minus. So give sodium AlOH4 Na plus minus 4 minus aluminum 3 plus. Right? So name sodium tetrahydroxo. Sodium tetrahydroxo aluminate. Aluminate 3. Okay, so the beryllium hydroxide and aluminum hydroxide both are reacts with the excess of sodium hydroxide to give complex. Same type of complex. Right? Right. Okay, students, the third similarity of beryllium and aluminum. The beryllium and aluminum ions have strong tendency to form complexes. beryllium 2 plus and aluminum 3 plus. Okay, so beryllium 4, 1s2, 2s2, 2p 0. In aluminum 13, in valence electronic configuration neon 3s2, 3p1, 3d 0. 3d 0, right? In beryllium 2 plus, beryllium the valence electron. Okay, so 1s2, 2p 0. In beryllium 2 plus, in loss of 2 electron in valence cell, right? So the empty orbitals are available. Beryllium 1, 2, 3, 4. So the 4 fluorine donate the lone pair of electron in empty orbitals. So the empty orbital contains metals involved in complex formation. So beryllium F4. Okay, so Fb F4, 4 minus 2 plus, so remaining 2 minus. Tetrafluoro berylate 2 ion. Tetrafluoro berylate 2 ion. Name of this compound, tetra means 4. Tetrafluoro berylate 2 ions. Right? And next, in aluminum 3s2, 3p and 3d. 3s2, 3p, 3d, right? So aluminum in valence cell 3s orbital, 3s, 3p and 3d orbitals. Okay, so 1, 2, 3, 4, 5, 3d orbital. 3s, 3p, 3d. Okay, so an aluminum contain 2 electron in 3s orbital and 1 electron in 3p orbitals. In aluminum 3 plus, loss of 3 electron. So vacant orbitals. Okay, so the 6 fluorine atom, 1, 2, 3, 4, 5 and 6 fluorine atom. The sp3 hybridization, sp3d2. sp3d2 hybridization. Okay, so the ligands donate the pair of electron to empty aluminum orbitals, vacant aluminum orbitals. Right? So aluminum F6. So Al F6. So 6 minus, aluminum 3 plus, remaining 3 minus. Hexa means 6. So hexafluoro aluminate 3 ions. Hexafluoroaluminate 3 ions. 3 the oxidation number of several metal ions. Right? Okay. So beryllium and aluminum ions have strong tendency to form complexes due to contain vacant orbitals. Are you right? The fourth one. The beryllium hydroxide and aluminum hydroxide are amphoteric in nature. Already you know that in beryllium hydroxide is amphoteric in nature. Aluminum hydroxide are also amphoteric in nature. So one time aluminum hydroxide act as a basic, in another one time so aluminum hydroxide act as a acid. The aluminum hydroxide reacts with the hydrochloric acid. So aluminum hydroxide act as a basic in nature. So to give aluminum chloride and water. Right? So 3 chlorine. Okay, hydrogen 3 plus 3, 6 hydrogen, 3 oxygen. Right? And aluminum hydroxide Aluminum hydroxide reacts with sodium hydroxide. Aluminum hydroxide reacts with sodium hydroxide. Okay, so to give sodium tetrahydroxo aluminate 3 ion Na plus minus 4 minus. Okay, so 3 plus 4 minus remaining minus 1. Sodium tetrahydroxo aluminate 3. Okay, so the aluminum hydroxide acts as a acidic in it. Okay, the aluminum hydroxide reacts with a strong base. The aluminum hydroxide acts as a acidic nature. The aluminum hydroxide reacts with a strong acid. The aluminum hydroxide acts as a basic in nature. So aluminum hydroxide are also amphoteric in nature. Aluminum hydroxide are also amphoteric in nature, right? So beryllium hydroxide and aluminum hydroxide are amphoteric in nature. The next one, beryllium carbide and aluminum carbide are also give methane on hydrolysis. Already you know that beryllium carbide give methane gas, evolve methane gas with water. Aluminum carbide Al4C3. Okay, 3 for aluminum, 4 for carbon oxidation number. So reacts with the water to give methane, evolved methane gas plus aluminum hydroxide. Okay, how many carbon? 3 carbon. How many aluminum? 4 aluminum. How many hydrogen? 3 into 4, 12. 4 into 3, 12. 12, 24. So plus 12. 12 into 2, 24. How many oxygen? 3 into 4, 12. So 12 oxygen. 12 oxygen. So beryllium carbide and aluminum carbides are give methane on hydrolysis. Right? The sixth one is the beryllium and aluminum are rendered passive by nitric acids. So beryllium and aluminum cannot react with the nitric acid. Okay, so rendered passive by nitric acids. மந்தத்தன்மை அடைதல். Rendered passive means மந்தத்தன்மை. அதுக்கு மேல react பண்ணாது. You right? Okay, the next chemical properties of alkaline earth metals. Chemical properties of the chemical properties of alkaline earth metals. Alkaline earth metals. You right? The chemical properties of alkaline earth metals. The reactivity of alkaline earth metal. The reactivity of alkaline earth metal is lesser than alkali metal. Okay, so alkali metal is a more reactive than alkaline earth metals. So alkaline earth metal is less reactive than alkali metals. Okay, so smaller size. Okay, less electropositive tendency. Right? Okay, so in second group, top to bottom, to increase the reactivity. Okay, to increase the size, to increase the electropositive nature. So easily loss of electron involved in this reaction. Okay, so the first reaction with halogens. Reaction with the halogens. All alkaline earth metals, beryllium, magnesium, calcium, strontium, barium. So radium is a radioactive element. The all alkaline earth metals react with halogens on heat to give metal halides. So M for beryllium or magnesium or calcium or francium or barium. So reacts with the halogens. X2 means chlorine, bromine, fluorine or iodine to give MX2 common formula complex. MX2 formula contain metal halides. For example, calcium reacts with the chlorine to give calcium chloride at heat. Okay, so the elevated temperature, the beryllium to barium alkaline metals reacts with the halogen to give metal halides, right? So the beryllium fluoride and beryllium chloride will not directly prepared. Okay, so the ammonium, the thermal decomposition of NH4 twice BF4, ammonium tetrafluoroberylate, ammonium tetrafluoroberylate, berylate 2 or berylate. Okay, so oxidation number of beryllium 2, so berylate 2. Ammonium tetrafluoroberylate. The correct way of preparation of beryllium fluoride, the decomposition, the thermal decomposition of ammonium tetrafluoroberylate to easily give beryllium fluoride. Ammonium NH4 twice BF4, okay, at 800 degrees Celsius to 1100 degrees Celsius. Okay, so 800 degrees Celsius to 1100 degrees Celsius heat. The thermal decomposition of the ammonium tetrafluoroberylate to give beryllium fluoride and ammonium fluoride. Beryllium fluoride and ammonium fluoride. How many ammonium? 2. So 2. How many beryllium? 1. Fluorine 4. 2 plus 2, 4. Okay. In beryllium chloride, the beryllium oxide reacts with the carbon and chlorine at 600 degrees Celsius to 800 degrees Celsius. Okay, to give beryllium chloride and carbon monoxide. Okay, the correct way of preparation of beryllium fluoride and beryllium chloride, the thermal decomposition of ammonium tetrafluoroberylate to give beryllium fluoride and beryllium oxide mixed with the carbon and chlorine at 600 degrees Celsius to 800 degrees Celsius heat to give beryllium fluoride. Gives beryllium chloride. Okay, so reaction with the halogen. The next one, the reaction with the hydrogen. Next, the reaction with the hydrogen. Reaction with the hydrogen. Except beryllium, all other elements, magnesium, calcium, strontium and barium. Okay, so directly react with the hydrogen on heating to give metal hydride. Okay, so for example, calcium directly react with the hydrogen at heat to give calcium hydride. So MH2, the common formula of metal hydride, the second group element metal hydride, MH2. Okay, but except beryllium, already you know that beryllium is a smallest size, high polarizing compound, high electronegativity compounds, okay, high ionization energy contained compounds. So cannot easily relieve the electrons. So oxidizing potential is very low. Cannot easily donate electron to the hydrogen. Electron to the hydrogen. Are you right? So calcium easily loss of 2 electrons. Okay, but in beryllium, so cannot loss of electron too easily in a smaller size. Okay, so except beryllium, all other second group elements gives calcium, metal hydride with the hydrogen at heat. Are you right? Okay, but in beryllium, the beryllium chloride and lithium aluminum hydride. That reacts with the beryllium chloride and lithium aluminum chloride to give beryllium hydride. Beryllium hydride from lithium chloride and aluminum chloride are also. So lithium chloride and aluminum chloride. 3 plus 1, 4 chlorine. So 3 plus 1, 4 chlorine. Beryllium chloride, BeCl. Beryllium chloride and lithium aluminum hydride. 3 plus 1, 4. So 2. Beryllium, 2. Hydrogen, 2 into 2, 4 hydrogen. 1 lithium, 1 aluminum. You right? Okay. So except beryllium, all other second group elements directly react with the hydrogen at elevated heat to give metal hydrides. In exception of beryllium, so beryllium is a low oxidizing potential contained element, so cannot easily donate the electron to hydrogen atom. But beryllium chloride reacts with lithium aluminum hydride to give beryllium hydride. Right? Thank you, students. We'll meet next class. Thank you.